part of today's press conference is being relayed by the Telstar communications satellite to viewers across the Atlantic, and this is another indication of the extraordinary world in which we live. So we're glad to participate in this operation developed by private industry, launched by government in admirable cooperation.
Hi my friends, in this video we're gonna talk about satellites. I wanna explain to you what I think about satellites and the flat earth. Well, it will be speculation, so don't tell me I'm wrong and insult me, it's just my ideas, okay? A lot of people in the flat earth community are saying satellites are a hoax and are not real, but I don't know, there are lots of companies that make satellites and work with satellites. I don't think it's all fake and fairy tales, but I also don't think the official story is what it is in reality, and most of those companies probably have no idea. First, let's have a look at the orbits. There are three different types. First we have low Earth orbit. Those are the satellites that are beneath 1000 kilometers. I think we could have some satellites there. Next we have medium Earth orbit. Those are satellites that are somewhere in between 1000 kilometers and 36,000 kilometers from the Earth. And then we have geostationary satellites. Those are at a distance of 36,000 kilometers from the Earth. I don't think it's possible we have satellites there. I have a few different reasons why I think that. First of all, how can you communicate with anything at that distance? Even through space, it doesn't make sense. I mean, my Wi-Fi cuts out when I'm on the other side of the street, so... And then there is the Van Allen belts. NASA always says they have so much trouble to get through it. Also, if we would have satellites over there, we would have thousands of pictures of the Earth. Now let's take a look at the different layers of the atmosphere. Satellites in low Earth orbit should be somewhere in the thermosphere or the exosphere. The temperatures in the thermosphere are somewhere in between 500 degrees Celsius to 2000 degrees Celsius. That's 932 degrees Fahrenheit to 3600 degrees Fahrenheit. At those temperatures, steel would melt, so a satellite would not even survive. Now if you ask NASA, they say, no problem, there are almost no particles in the air because it's a near vacuum, so you can't feel the heat, you need the particles to transfer the heat. But that's not true because temperature easily changes in a vacuum. Someone did an experiment a while ago testing the temperature in a vacuum by putting the vacuum box outside in the sun and putting it in the shade, and the temperature was changing quickly. I was trying to find the video, but it seems that YouTube deleted it and I could not find it again. There are probably extreme temperatures at that altitude, but I don't think the temperature runs up to 2000 degrees, I think it's a lot less. And I also don't think it's a vacuum up there. So, how would I make a satellite? Let's say I want to make a space station for my cat. How could I do that? I could start with buying one of these. Place the cat inside, lock the door. We're not gonna worry about temperatures or oxygen for now, it's only a test flight. Now, how can we make it float? Oh, I have an idea. We could attach it to a helium balloon. Let's see if this works. If this works, I'm gonna be famous. I'm gonna call it International Cat Station. It seems to work so far, the altitude is increasing. My cat seems to be cold right now. I think next time we need to add gold foil. Well, I think I did it. That's how you make a satellite. Oops. Houston, we have a problem. Not that big of a problem, I have a second cat. Damn, that didn't work. Let's look at how satellites are made.
So what we've got here is the overall service module, or the startings of the service module of the telecommunications satellites. What you can see are 2 tanks of an eventual 4-tank propellant system. On the outside, in several locations, we've got 7 smaller thrusters, and we have a main engine, a liquid apogee engine, which is fitted inside the cone.
The service module carries 4 fuel tanks, all placed around the central core. Each fuel tank can withstand an internal pressure equal to being over 200 meters underwater.
That's it, we need big tanks that can take the pressure and fill those with helium. Not propellant, helium. Imagine they can lift the cat and take the pressure. Would the altitude keep increasing? Helium rises up because it's lighter than air, but if you look at the properties of the thermosphere, you will see that it's made out of mostly helium. So in theory, if you get there, at some point it should start to float. Yay! Our cat is floating! Now we need to get it in orbit. Well, I think that's a pretty simple one. If you look at the wind streams at higher altitudes, or even at most altitudes, you will see that it makes a big circle above the equator. There is this weather tool that allows you to see the wind streams on the flat Earth map, and you can clearly see it makes a big circle. There are also people that circumnavigated the Earth with a balloon and use those wind streams. It's also important we prevent the satellite from spinning. When I spin my cat around very fast, she gets dizzy and throws up. We don't want that. So I was thinking maybe we can use the solar panels like ailerons on an airplane and take more advantage of the wind. Or, just to be sure, we can add a tank of rocket fuel and some nozzles on every side. Well, that's how I would make a spaceship. That's ridiculous! Yes it is, but it's probably a lot cheaper than NASA. And I bet it's also a lot more fun. For cats. But I don't take credit for it. All the credit goes to this guy. He invented the satellites.
We're talking today with Arthur Clarke, the man responsible for communication satellites. Mr. Clarke, you've said not too long ago that in terms of communications, we're still in the semaphore and smoke stage. Would you put that in context, please?
Well, as far as the home is concerned, we have TV and radio and telephone. The telephone is the only way we can communicate outside yet. We get a lot of communication inwards through the radio and TV, but we're going to get devices which will enable us to send much more information to our friends. They'll be able to see us, we'll be able to see them, we'll be able to exchange pictorial information, graphical information, data, books and so forth.
What would the ideal communications device be in your eyes?
Well, it would be a high-definition TV screen and a typewriter keyboard, and through this you can exchange any type of information, send messages to your friends which they can read. They can wait when they get up, they can see what messages have come in the night. You can call in through this any information you want, airline flights, price of things at the supermarket, books you've always wanted to read, news. You selectively, you can say, you'll tell the machine, I'm interested in such and such items, sports, politics, or so forth, and the machine will hunt the main central library and bring all this to you selectively, just what you want, not all the junk which you have to get, you know, when you buy the 2 or 3 pounds of wood pulp, which is the daily newspaper. And incidentally, this is going to save whole forests for posterity, because the newspaper is on the way out, and we're not going to ship all this tons and tons of paper around when we